Hello and welcome back to MLab 1101, Introduction to Clinical Laboratory Science. My name is Dustin Scott Brewster, and this is going to be the first of a three-part presentation for the third unit for this course, Laboratory Math. Before we start talking about laboratory math, let's first establish units of measurement. There's two basic units of measurement. The first one is the standard system, which was originally based on human anatomical features. There was obviously a lot of variation in this, but it's since been standardized. It does not use a decimal place, and so it's not as accurate. Because of its conception and how it was originally based on anatomical features, it's a little more difficult to convert than the metric system. The metric system, on the other hand, is built on a unit of 10 scale. This will make more sense as we start talking about conversions here in a second. It does use a decimal system, and so it makes it more accurate for measuring small quantities. Again, because of its basis on a unit scale of 10, it makes it easier to convert between units. So the standard system is practiced in very few countries. Unfortunately, the United States is one of them. Other countries include Liberia and Burma, and those are the only countries that still predominantly practice the standard system over the metric system. The metric system, on the other hand, is practiced everywhere else. And because of its accuracy and its ability to measure small quantities with a decimal place, it is the best unit of measurement for science and medicine. A type of the metric system is the International System of Units, or the SI scale, and it is a form of the metric system that has been adopted for use by the worldwide scientific community. So the metric system for laboratory science and medicine is going to win. It's more reliable, it's more accurate, it has the ability to measure small quantities, which makes it an ideal candidate for laboratory science. So the base units for the metric system include, for distance, we use the meter, or the unit symbol lowercase m. For measuring mass or weight, we use the gram. The unit symbol for gram is the lowercase g. For measuring volume, the base unit is the liter, and we use the unit symbol capital L for liters. So prefixes, which is a word before the root word, is used to indicate larger or smaller quantities of the base unit. We'll talk about prefixes. So kilo is a prefix which represents 1,000 times the base unit. For example, kilometer is 1,000 times the base unit of a meter. So there is 1,000 meters in a kilometer. Centi, if you want to measure a smaller quantity or a smaller amount, would be 0.01 times the base unit, which means there would be 1,000 centimeters in a meter. Milli, working our way down, is 0.001 times the base unit, and so on and so on. Micro is 0.000001 times the base unit, and nano is times 10 to the negative 9th. Pico is times 10 to the negative 12th. So you're going down to measure a smaller quantity. So to convert between units, it makes it a lot easier to use an acronym. I made up this acronym here. Feel free to make up your own if it helps you memorize it. But in this example, we use King Henry dances boldly down center main micro. And so what does that mean? That acronym up here, the first letter of each of these words represents the unit of the prefixes in the bottom row. So King is for kilo, Henry is for hecto, dances is for deca, boldly is the base unit, down is for deci, center is centi, main is milli, and micro is micro. So let's put this into action. Let's convert kilograms to grams. So how would we do that? So kilograms is over here, and we want to know how many grams are in X number of kilograms. So the first thing we need to do is we need to find out where is grams. Grams is a base unit, so that's over here. So we're going to start with kilograms, and we're going to move 1, 2, 3 places to the right. So in this example, we have 30 kilograms. We want to know how many grams is in 30 kilograms. So again, we start right here, and we move 1, 2, 3 places to the right. So right here, 30 kilograms, the decimal is going to be after this 0. We move 3 places to the right, 1, 2, 3, and we get 30,000 grams. So 30 kilograms is equivalent to 30,000 grams. So let's go the other way. We want to convert centimeters to meters. So let's find centi on our conversion table. And where do we want to go? We want to go to meters. Meters is a base unit, which is right here, which means we will go 1, 2 places to the left. So move the decimal 2 places to the left. In this example, we have 30 centimeters, and we want to know how many meters is in 30 centimeters. So the decimal is after this 0. We move 2 places. 1, 2 places to the left, which means 30 centimeters is equivalent to 0.30 meters. So all units in the SI system can be qualified by standard prefixes, which we talked about in the last 2 slides, and those can be used to convert values to a more convenient form, depending on the size of the object you want to measure. So a good example is the distance between Austin, Texas and Houston, Texas. I'm not exactly sure, but I'm going to say it's about 20 kilometers. But what if somebody doesn't give you the distance in kilometers, they give you the distance in meters? So somebody tells you the distance between Austin, Texas and Houston, Texas is 200,000 meters. So we'd want to go back to our conversion table. So we have meters. Somebody told us the distance between Austin, Texas and Houston, Texas is 200,000 meters. Meters is the base unit. We want to know how many kilometers it is. Let's work with a more convenient number. So it would be 1, 2, 3 places to the left. So if you had 200,000 meters, we want to know how many kilometers it is. So our decimal is right there. We go 1, 2, 3. So that means there are 200 kilometers in 200,000 meters. So it allows us to convert between units in a much easier way. So that's another one of the key benefits of using the metric system. Another thing to note, especially when dealing with large quantities like that, is that commas are not used as spacers in recording large numbers. So you wouldn't record 200,000 or 200, comma 000 like you would normally see. Instead, when you use the SI system, you would write that, and this is just a random example, 30, comma 000 would be written 30 space 000. Another totally random number is 304,431. You would write that using the SI system as 304 space 431. So unfortunately, not every place is going to use the metric system, especially in the United States where the standard system is predominantly used. You will eventually have to convert between the 2 units of measurement. To do that, if somebody gave you, for example, miles, and you wanted to know how many kilometers were in however many miles somebody gave you, you would multiply the number of miles that somebody gave you times 1.6, and that gives you the answer in kilometers. You can convert down the table here. Somebody gave you a number of pounds. You want to know how many kilograms are in X number of pounds. You multiply your known value times 0.454 to find your answer in kilograms. Working your way down, somebody gave you a value in quarts. You want to know how many liters is in X number of quarts. You take your known value, in this case it would be quarts, you multiply that times 0.95 to get liters, and so on down the list to convert from standard to metric. So the base units for the SI system, as we kind of talked about some of these, for length we're going to use the meter or the unit symbol lowercase m. For measuring mass, we use the kilogram or the unit symbol kg lowercase. For measuring time in the SI system, we use the second, the unit symbol lowercase s. To measure the amount of a substance, that is measured using the mole or the unit symbol mol, all lowercase. To measure electrical current, we use the ampere. The unit symbol capital A represents ampere. To measure temperature, we use the unit Kelvin, or the unit symbol capital K to represent Kelvin. To measure luminous intensity, we use the candela, or the unit symbol lowercase cd. And to measure volume using the SI system, we use liter, or unit symbol capital L. Another really common thing that you're going to have to convert between standard and metric is temperature. Typically in a clinical lab, you're going to find things are measured in centigrade. However, if somebody comes in and they report a fever of 98.6, well, let's find out what 98.6 is in centigrade. So to convert from Fahrenheit to centigrade, let's use this symbol here. Degrees Celsius equals 5/9 times 98.6 minus 32. So going in the correct order of operations, the first thing we do is find out the answer inside the parentheses. So the parentheses first, 98.6 minus 32 is 66.9. After the parentheses, you would do multiplication or division. In this case, we have a multiplication problem. 5/9 times 66.6 is 37. So our answer here is 98.6 degrees Fahrenheit is equivalent to 37 degrees centigrade. So let's go the other way around. So let's convert from centigrade to Fahrenheit. So how many degrees Fahrenheit is 22 degrees centigrade? So for example, somebody tells you, why don't you make the room in here 22 degrees centigrade? So let's find out how many degrees in Fahrenheit that is. Let's use the formula here. Degrees in Fahrenheit equals 9/5 times centigrade plus 32. Our known value is 22 degrees centigrade, so we plug that in here. So we have 9/5 times 22 plus 32. Again, going in the correct order of operations, we do multiplication first. So 9/5 times 22 is 39.6 plus 32 is 71.6. So 22 degrees centigrade is equivalent to 71.6 degrees Fahrenheit. So non-SI units that are commonly accepted in the clinical lab include minutes. We talked about an acceptable unit is seconds to measure time, but we can't always measure everything in seconds. So we commonly use minutes as a non-traditional SI unit in the clinical lab. Additionally, we measure things in hours. Lowercase hr is the unit symbol for hours. Days, unit symbol for that is the lowercase d. And another common thing which you'll see throughout medicine is pressure. To measure pressure, we use millimeters of mercury, or mm, capital H lowercase g for the unit symbol for measuring pressure. And this is millimeters of mercury. That's what we use for finding somebody's blood pressure. Another common thing you'll see more specifically in the clinical lab is enzyme activity. To measure enzyme activity, we use international units. and that is represented by the unit symbol capital I, capital U. So we'll pick this back up with part 2 for laboratory math, and that'll conclude the first part of this presentation series.